Okay, so Tony from AWS, our next speaker, will walk through the journey from Monolith to microservices to service mesh. So just please welcome him and enjoy.
Good afternoon. Yeah, it's great to be here. Inaugural service mesh day. Good afternoon, everybody. I'm going to talk a little bit, briefly, less than 20 minutes, on Thanks. Yeah, that's better. Thank you. All right, so I'm going to blow through this beginning. You're on your journey, and this is going to put fear into everybody's hearts. This is a real screenshot from one of our customers. This is Edmunds.com. A lot of traffic. They've got a big website. They've got a lot of traffic. They've got a lot of services. They've made this journey to microservices over the past few years. And, you know, that's what we're here today to talk about service meshes for, right? We understand how to manage a reasonable amount of services, but when you look at a graph like this, this is pretty challenging. What if your services, what if you're not ready to containerize everything? We assume in most of our discussions that we're containerizing. What if you want to take advantage of different compute services? What if some of this is going to be running in VMs? Some of this is going to run serverless. Some of this is going to run under in Kubernetes, EKS, or ECS, different container orchestrator altogether. What if you want to mix and match? You're just not ready to go 100% shift over tomorrow to something like this that's all running on Kubernetes. So that's what I'm here to talk about. We have this vision around what it means to have application level communication or application level networking within your mesh. And historically, when you set up your services, one of the first things you have to do is configure all of your networking, what we call your VPC. And if you're running microservices, what the developers really care about is how these services are going to interact with the other services. They care about that communication. They don't care about it, at the CIDR block level. They want to know, how do I talk? How do I find my other services? What happens when I update services? How can I shift traffic from this version to this version? How can I do A/B testing? That kind of stuff. And so, step one for our vision on this, we announced AppMesh yesterday. We went, it's generally available right now, and we've got a service mesh that allows you to transcend or span all of these different compute services backends. So whether you're running under ECS with our classic container orchestrator or EKS with Kubernetes, Fargate, which is yet another compute model, or even soon Lambda, you've got something that will allow you to get some control, some visibility and management over your mesh. So let's take a look at a very simple case and just dissect this. We've got service A, and it communicates with service B. But even in a simple little model, if I've got two different teams, and one team is developing in Java, and another team is developing in Go or Node or something else, what do I need to do if I want to have unified visibility, observability of my application, a unified view of the logs, the metrics, the traces? How do I handle shifting traffic if I want to roll out another version of B? How do I handle these kinds of problems and do it in a way that relieves burden and makes it consistent and uniform for my teams? So what we do is we leverage Envoy. We use a proxy. We put a proxy between our two services, and that's part of the how we solve the problem on the data plane side. And then we provide a control plane, which allows us to specify the configuration, the policies that we want to apply and enforce across our cluster. And this control plane is what pushes out those policies to all the Envoy proxies running in this cluster at scale If you take a look at that first picture I showed you, that graph, it's a massive scale. Why do we use a sidecar proxy? Well, because it's generally pretty difficult to solve some of these problems without a proxy. It's not the only way to solve the problem, but as with other projects, it's a very effective way of getting the decoupling that we wanted, to be able to apply your configuration that's consistent and can be uniform across not only the different programming languages, but all the different compute environments I was talking about, those compute services, compute primitives. This allows you, of course, to separate your configuration of that routing, those policies, those rules, and get the visibility support that you need independently from the business logic of the code that you're actually deploying for your services. And again, to enforce that, you get this uniform approach towards getting all of your services to participate inside of your mesh. It's a simple model if you're running containerized, if you're using ECS, for example, or EKS, tasks or pods. It's a straightforward model to have a sidecar where the life cycle of that proxy is coupled to your service that you're deploying. It's not the only way to do it, but if you're containerizing, this is going to be the approach that you're going to take with ECS or EKS. And we do use Envoy, and of course we picked Envoy because it's a very successful, very battle-tested product. It was designed specifically for solving the problems that we want to solve inside of a mesh. Great community support. It was the third project to reach graduated status in CNCF, which is definitely a badge of credibility, stability. And our own internal testing has definitely proved to us that Envoy could meet the scale requirements that we needed. So our control plane is what provides these updates to all of those proxies running, coupled to all of those services running inside of your mesh. It's the control plane that pushes out configuration and then provides dynamic updates to your service mesh to those proxies that need to be updated. And not every proxy needs to get updated at the same time. We push out configurations to the ones that give them what they need to know to reach their upstream services, their backends. So not every proxy in the cluster, there is no global configuration that gets pushed out to every single service. So it's very optimized, it's very tuned. And by the way, it makes it resilient. So just because one service A can't CC, that doesn't mean that service B can't CC. And there's other things that are related to the dynamic state that we deal with. So we push out that configuration. It's important to note that while we're keeping it up to date, again, all the communication between your services is running within the data plane. There's nothing that goes back through the control plane. It's just service talking to service once it's been configured. So with application visibility, what it means, in the mesh is that we're looking for this consistent, uniform approach to collecting the things that are important, your logs, metrics, and tracing. Logging, sort of, it's like classic Apache logs, right? It's your web server logs. It's not talking about the logging that your application might be doing as far as its business logic, but we're talking about application of all the, let's say it's, your HTTP services, all the requests that are going, the routes that we're getting hit, which HTTP verb is getting used. But you get that for free. So every one of these services in the mesh, regardless of where it's running, which compute backend service, we're collecting logs from the proxy instances, from all the envoys that are running. So because they're the intermediary for each service, we've got the logs coming out of Envoy. We collect that. We're collecting your metrics, which are your aggregate statistics, things like how many bytes received or sent, HTTP 500s, and that kind of stuff. And you get that also for free. So you get that, again, because Envoy is sitting there as a proxy to your service. So all ingress and all egress is flowing through Envoy. This is Envoy's instrument. We can collect that and provide that visibility to every participating service in the mesh. Tracing allows you to follow that chain of requests, and that's useful to identify issues, for example, latency, other types of performance issues. You almost get that one for free. You do have, the way distributed tracing works, you do have to complete the segment through your services. So you have to instrument your code to provide that gap from a request coming in correlated to whatever goes out. But we have distributed tracing enabled that collects the Envoy part of the ingress and egress traffic. So, and this is important. You want that because Envoy is what's providing that routing control. It's what's doing the routing. So those routing decisions that get made and performed, you want to be able to see that in your distributed tracing graphs. In terms of I talked about observability. In terms of the client-side traffic management support, there's two different categories, broad categories. On the traffic shaping side, you've got the load balancing. So where service A may be talking to service B, but service B's got 50 containers, 50 pods out there running, backing that service. The load balancing is getting handled by Envoy, and so that's what we mean by load balancing, client-side load balancing. There's no load balancer running out there. It's running in your data plane somewhere or in our control plane. Weighted targets allow you to distribute traffic so that you can balance. You can do canary testing or A/B testing, and in fact, blue-green, shifting all of your traffic 100% from one to the other. We got weighted target support, and then service discovery means when my services are participating in the mesh, I've got the standard, consistent, uniform way of finding all my services. It's not container orchestrator specific or compute service specific. You want all your services running in your mesh to have this way of being able to find all your other services. So that's what that means. And then the other things, things like being able to reach, a uniform mechanism for applying retry logic and timeouts and circuit breakers. So when something in that chain of requests breaks, you don't want to consume time and energy in that system to continue trying to talk to one of the bad to a pod that's not responding. You want it removed from traffic, and so the mesh is going to handle that for whichever service, whatever compute backend is on. We'll provide that, and then we've got all our routing control support, like things like distinguishing between HTTP and TCP and gRPC coming soon, and path-based support. So, for example, HTTP routes, be able to say I want traffic on this route to go here, traffic on this route to go there. But I can apply that as a routing rule. Header-based, cookie-based, host-based, those are all forms of routing control. So I already said this, but I want to use Nick Colt, our product manager, who's sitting back there. I'll take his joke from yesterday. If you haven't heard the news, then I'm the first to tell you we've gone GA. If you've already heard, I'm so happy to tell you. We are GA as of yesterday. You can actually start using this right now. And that means you can start using it in production. And here you go, observability and traffic control in terms of everything I just discussed. Running on ECS and EKS and Fargate right now, and EC2 as well. And we're going to show this in a demo in a moment. So in terms of constructs, there's two things you do when you configure your application to participate in the mesh. The first part is you configure your mesh resources, and I'll show you what those look like using our console. You can of course use the console or the CLI or the API to configure the resources that apply. And then there's your, on the service side, your part of the application. Deploying your application means also deploying your Envoy proxies with it. Whether they're sidecars in your tasks or your pods or installed on your instance whatever. So there's an app that you can test. Nick Holt actually wrote this up. And there's a URL for it. It's a little long to type on the phone, so if you want to try it or your laptops, there's a bit.ly link as well. You can go to that right now. In fact, the more people that do actually hit it, that'd be great. So we can have some traffic, which I'll demonstrate here in a moment. So while people are getting ready, maybe opening up that website and pinging it, let's take a look at what we've got. The simplest possible model so that we can really make these concepts clear. Obviously, you take this and you extend this no matter how complicated your application becomes. But in this example, literally just two services, an A and a B, that have to talk to each other. So in this case, we've got the front end to the application, our gateway, and we've got the actual service implementing the business logic that we wanted. Well, we have several different types of them. So the application has a route / color, and it's going to talk to a backend service that actually responds with a specific color. If you hit it right now, you should be seeing red. And so how the first service talks to the backend service is it looks for a color teller.local. And that's using the service discovery feature of Mesh. The service is identified as color teller.local. That's all the gateway service needs to know about. It's going to talk to color teller.local. Now, when you take this application, you meshify it. What that means for us is creating those mesh resources using the console or the CLI or programmatically with the API to define the resources around it. So your virtual nodes, your virtual service, and apply routes, the rules that are going to govern the traffic itself. So you can see that Gateway's got an associated envoy, and Color Teller's got an associated envoy. Above here, there's an integration with CloudWatch and X-Ray, and AppMesh is the AppMesh control plane is what's pushing configuration out to these two services. Oops. So, demo. Oh, it switches up there, but it doesn't switch for me. Why is that? It's let me try and get it back, and let me figure out what I need to do here. I don't know why the screen won't switch, so let me just do this manually. Okay, so there we are. Everybody should see red if they're hitting the service. This is configured with AppMesh. This particular application is called Color Teller. It's the only one running in this cluster right now. So we've got Color Teller, and it has the resources that it needs, virtual services, and there's one, colorteller.local. We've got our virtual routers. We've got our virtual nodes. Okay, so what does that mean? The virtual service represents the service that we're going to want to hit. Okay, that's the service that we've registered that A is going to use to talk to B. Our virtual nodes our virtual nodes, you're going to have a virtual node for every service that you want up. The service code that you actually deploy. So everything that's going to run in the cluster, and every version of it is going to have a node. So what I defined here is a gateway, and there's color teller blue, color teller green, and color teller red. Those are the actual service instances or virtual nodes that are providing the service functionality that we want. And under virtual routers is where we have defined our route rules. And let me blow this up a little bit. And as of right now, in this route rule that I've got, which is based on an HTTP route for all traffic going to root right now, 100% of our traffic is going to the red service. Okay, so that's what we're seeing. Now, if I decide to switch that, and let's say I want a 5-to-1 ratio, or 3-to-1, it doesn't matter. Oops. If I start pinging, I should show green show up, red will show up more of the time, okay, as you would expect according to that ratio. It takes effect right away, near instantaneous. Okay, so now that I've done that, let's go ahead and take a look and see what that looks like inside of our distributed tracing graph. Let me update this. I actually should have, let me refresh. What we should see when this refreshes, tell you what, I'll wait a second while for it to refresh. We've got logs. So let's pick this one. Even if you didn't instrument any logging inside your application, we've got logs showing up right now for all the, looks like a lot of traffic, so people are hitting it. A lot of people have hit it. All the people hitting the app are generating traffic that we're collecting here in the logs. And at some point, my X-ray graph should update. There we go. I don't know why that took so long. What we're seeing here in this very simple example is that we've seen our request came into the gateway. And initially, the gateway sent the first requests were only going to red. And so they're hitting the proxy instance right here for red. So that is showing the traffic going to the red service. And then we also started hitting green. Sorry, blurry on my end. Yeah, so we're hitting, here we are, we're hitting green. And it looks fine up here. Okay, so I'm sorry, everybody, a little blurry on mine. So again, here are our, here we're hitting the proxy for our gateway service, and our requests go to the gateway and come back from it, and then our requests get sent to the ultimate destination service according to those routing rules that we configured. Something I want to point out about this while I'm here is that the gateway is running in a container on ECS. Color teller red is actually running as a node app on an EC2 instance. And color teller green is a Go app running in 3 pods on EKS. Okay, so this is running across different compute backends, different container orchestrators, and they're all participating in the mesh. Yes. Sorry. Is what was the question? Is the first one what? So right now, AppMesh is all this internal service to service. So in front of that, where it says clients coming in, we're actually hitting an ALB. So it's hitting a public load balancer so that you can hit it from the internet. And then from there, traffic's getting sent to the first service, getting intercepted by Envoy proxy running inside the mesh for that first service.
And do you attach a sidecar to that ALB?
No. So right now it sends the traffic to the mesh, and then the mesh starts load balancing, applying rules to get it to where it needs to go once it's inside the mesh. I'm about to run out of time, so let me get back to this. And I apologize, I was so blurry on my side. Not sure what's happening. Okay, so we are really happy that we have so many partners right now. We've got 13 today, including the host here, Tetrate, on the list. Nick did a Twitch stream yesterday demonstrating some of our partners' observability integrations and deployment controllers and things like that. And we definitely feel that AppMesh works better with all of the partners that we're working with. We've got a public roadmap now. In our desire to increase transparency around the work that we're doing and get more participation and focus on things that our customers want, our roadmap is actually public. It's on GitHub. I'll show you the link here in just a moment. But here's a list of things that we have today, and I'll go fast. The list of things that are coming up, and then a little bit longer term are the things that we know are important that we want to do, like MTLS, mesh peering, where you can have meshes talking to other meshes. But the near-term things, you can look forward to a lot of things on this list pretty quickly. So here are the links if you want to get started. Product overview and docs, things like that. Excited to mention that on this list, it worked well for us during the public preview, and so we want to build on that. We're opening up a beta channel, which means that you don't have to sign up, you don't have to do any of that. It'll be public. You'll be able to use the version that's in production right now, or you'll be able to use the beta channel to play with features as they get added on that list that I just showed you. Here's my contact info. You can send me a DM on Twitter, or you can email me if you want to chat further, ask questions, whatever. Happy to provide any help that I can. Hope you have a chance to check out AppMesh.
Thank you. And there's time for your questions. If someone wants to ask some questions now, there's time for that.
Yeah.
Is this extendable, like with this here you can have a... Is this extendable, like with this tier you can have a mixer gRPC based adapter to extend it? Can you do that with AppMesh?
So right now the extensibility mechanism is based on just what you can do to extend Envoy, which is open source. We've got if you take a look at it, if you go look at the docs, we've got a very straightforward API that defines a set of operations that are available, but it does include all the hooks that you need to be able to plug into it for providing observability functionality, policy management, identity stuff, deployment controllers, and things like that. So yes, it is designed to be extensible. Take a look at the docs to see exactly what hooks are for that.
Yeah, I have a question. What are the thoughts you have as far as Istio users, their YAML file being reused in AppMesh? Do they have to start from scratch to recreate their YAML files for different configuration for the service mesh? What are the thoughts in this space?
So that's a good question. That's an interesting question, and we definitely want feedback from how important that use case is for customers. So, and that's where you want to go to the GitHub link that I mentioned there. Provide some feedback about how this helps you in your use case, and we'll definitely take a look at that. Right now, we were focused on getting this cross-mesh functionality in place. And so we didn't spend a lot of time focused on any one type of configuration model that was specific to either type of service or container orchestration engine. That doesn't mean that there couldn't be ways of improving that experience and make it easy. Right now you can run Istio. That's not a problem. We have lots of customers running Istio with their Kubernetes deployments on AWS or with managed EKS. But they are different configurations right now. The configuration for AppMesh is fairly straightforward. It's it's I'm trying to think of, let me give yeah, I would say that if you have a specific idea of what you would like to see supported out of that configuration, what's important to you, put it up on the GitHub, put it up on a GitHub issue, and help us understand the use cases. Thanks. Yeah.
Sorry, man. Just a quick clarification about what you were saying before about the extensibility. So the extensibility that you're talking about, that's when you say it's done with Envoy. It's Envoy filters that you're.
Yes.
Sort of
Yeah. Whatever you can do right now with the open source part of the project.
Yeah.
That's available through plugging into and extending or enhancing Envoy.
Right.
We'll be building on that to make it easier for you to add custom,
Right.
through the API, custom
Okay.
configuration.
So I guess the question that I had was just about, like, so the stuff that you built for, say, plugging into X-Ray and all that sort of stuff, just to pick a
That's
specific thing.
good point. Yeah.
Is that then? So I haven't had a chance to look at the repo yet. Do you have like your own set of Envoy filters that you provide that people can compile into their own ones, or do you have a version of Envoy that has that you can then?
Really good question. Really good point. So to rephrase that, do you need a custom? Are we using a custom version of Envoy? And related to that is, did we, like the X-ray integration. So one, the X-ray integration, that's open source, and we've contributed that back upstream. We've contributed other things upstream, like SIG-v4 support for the endpoints. No, you can bring your own Envoy. There is a version that you can pull that and add as a sidecar that has a bunch of functionality stuff bundled in already, sort of like a standard version. But you can use your own Envoy, and you can configure it.
Yeah, the reason I ask is that so far, it's likely that we will already need to plug our own extra stuff into vanilla Envoy, so if we wanted to use AWS, we would need to do it, but we'd also be interested in doing things the other way, maybe pulling like the X-ray thing and putting it in some other Envoy, and so that's why I was asking this question.
Yeah, so
probably something we'll talk more about later if we're running out of time.
Yeah, you might want to correct me if I'm wrong, but I do believe we're going to be adding support through the API to be able to extend Envoy configuration. Is that on the roadmap, or? Possibly. Okay. Yeah, you can. But you can definitely bring your own Envoy. So. Yeah. Okay.
One question, okay, so I have two questions. But I think one question is, first one is the sidecar right now is a container, or you mentioned EC2, right? EC2 based on
Yeah, you can run it as a container. You can. You don't have to. You could install Envoy on an EC2 instance.
It will, auto scaling itself, or I have to handle the auto scaling.
Well, so depending on what you're going to do, unless if you install it, just as a service on EC2, then you probably want your EC2 instance to be part of an auto-scaling group or something.
Right.
But
so the sidecar.
your sidecar, you mean when
the
if it's in a
scaling
pod or
of-
in a task, your pod or task is going to be the unit of scaling.
Right, but how about I say if my service running on EC2 has a ESG, then who handle the scaling of the?
I mean, if you're going to manage your own instances, you're going to
manage myself.
if you're installing services in your own VMs, you're going to manage that separately. That basically just gives you the ability to start participating in the mesh without containerizing. But
Okay. The second question is, you mentioned there in the longer-term roadmap you have a mesh period, right? So the question is, like, right now, what's the boundary of app mesh? Is it bound with an account, or is it VPC, or what's the current boundary that can mesh?
your current boundary is your VPC on AWS. So take a look at the issue go to GitHub and take a look at the one on mesh peering, and take a look at what's there and add thoughts to that if you have thoughts. But that literally is going to mean that your mesh that you create should be able to communicate that's not even well defined at this point, what it means to communicate with another mesh. But yeah. Yeah.
So if anyone has further questions, we can ask him later. You will be
Yes,
around
yeah.
probably. So just want to make sure every speaker has his time. So just thank you.
Thank you.
Thank you very much.
Appreciate it.